Hi, in this video, I'll show you how to perform survival analysis in SAS. We will study three things: how to use PROC LifeTest in SAS to do the Kaplan-Meier estimation. Just to remind you, Kaplan-Meier estimation is one estimation method that is used to estimate the survival function. Then we will learn how to interpret the product limit table which comes as part of the result in the estimation process, and then finally we will learn how to interpret the survival curve. For this illustration, I have taken a medical data set. There are 500 patients who have gone through medication and the medical authority wants to know that how many of them are surviving beyond a certain period. Okay, look at the data set that you can see on the screen. ID is the customer ID, or sorry, the patient ID. I have got 1 to 500, so there are 500 patients in total. Length of follow means till what time they were in the study, the patient was in the study. Then f stat is the status of the patient. 0 is surviving, 1 is the person died. So the event of interest is dying or death. As you know, survival analysis is a kind of modeling where we model the time to event. So if you look at the patient 4, the status is 1. That means the patient has died at what time? At 297th day from the date of medication. Okay. So what is the sensor variable in this case? The sensor variable is the f-stat. You will see so many cases where the patient is surviving and or the patient has dropped out from the study. Okay, and these cases are censored cases. So the f-stat variable indicates whether a patient is having the event, which is death, or it's not having the event, it's surviving till the end, or it's dropping out from the study in the the length of the time period that is followed. So I assume that you do it before doing the analysis. You have to use the proc means proc frequency to do the exploratory data analysis before doing the modeling work. I'll straight away go to the modeling. PROC LifeTest data medical. I'm going to write here at risk. So this is an option which gives you how many people or how many patients are at risk at different time point, and then I'll plot the survival function. Then time, length follow, f-stat 0. Let us understand the syntax. PROC LifeTest is the proc that is used for estimating the Kaplan-Meier function. At risk is something that is used to know what is the count of patient at risk at different time points, and then we use the plots for plotting the survival function. In time, we need to mention that what is the time period of following the particular event. Length follow or LENFOL that particular variable is our time or the duration for which the patient is under study. And then f start is nothing but the censored variable, uh, and what is the value that shows censoring? Well, it's 0. If it is 1, then the event has happened. What is the event in this case? It's death. If f start is 1, then the patient has died within the study period. If the status is 0, it hasn't died, or it's a sensor case. We have no clue what is happening with that patient after the study period. And then run. Let us run this. You can see on the screen the product limit survival estimate. Let us understand this first. Number of people at risk, number of patients at risk, 500. In the 0th time, everyone is at risk. Nobody has died. Okay. Then in the first day, on the first day, one person died, and then second person died, and gradually 8% in total died on the first day. Not 8, it's yeah, it's 8% died. So on the second day, before the second day, 8 people have died in the first day itself. So total number of people who are at risk in the second day is 492 now. The survival probability is 1 in time 0. That means the probability that individual will survive beyond time 0 is 1. Everybody is going to survive. But after time 1, when 8 people have died, the survival probability decreases, obviously, because people are dying now, and then the probability of surviving beyond time 1 reduced, and it is reduced to 0.98. And then there is a corresponding failure also. Failure means your death. Survival, it's the complementary. It's just 1 minus 0.984 is your 0.016. So your failure rate is like 1 minus your success rate or your survival rate. Okay. In the time period 2, again 8 people are dying. So for the time period 3, your survival probability decreases to 0.96, and so on. It will go on decreasing, and then the number of people at risk is going to go down with time, and there will be a point. This will go on till the number of time points we have. We are having in total 2358 time points. Till that time point, we will be observing what is happening to these patients, and how many people are at risk, and what is the survival probability, and so on. The survival probability, as you know, it's unconditional probability. That means it's not conditioned on the fact that how many people have died previous to that. So it's completely independent of that. All you know that what is the probability of survival beyond a particular time t. That t will varies from 1 to your end of the period. You have more than 2000, so from 1 to 2300 time point. When you plot this survival probability at each time point, you get a survival curve. You can see on the screen. In the x-axis is the survival distribution function, which takes value from 0 to 1. It's nothing but the probability. At time 0, everybody is surviving, so the probability of survival is 100% or is 1. Okay, but at time goes, the survival value or the probability goes down gradually, and by the time it's the 500th day of the study, you can see 25% of the population have already died. Only 75% are remaining, or in other words, how do we interpret this? Well, beyond the 500th beyond 500th day, the probability that a patient is going to survive is 0.75. Similarly, at 1000th day, you can see on my marker 1000th day, the probability is somewhere around 0.65. So the probability that a patient is going to survive beyond 1000th day is 0.65. Similarly, it's zero point 0.5 on the 2000th day. Okay, that's how we interpret the uh, uh, survival curve. Why is it so interesting to us? Because we get to know that how the events is happening, at what rate it is happening. We can compare different survival curves across different you know different categories. For example, we can do it for male and then do it for female and then compare. How do we compare? We compare in such a way that what is the mortality rate and how do we see a difference between male and female population. So these are the cases where we use the survival function. And one of the peculiarity of survival model, you might have already have this question in mind, that what is a dependent variable, what is a independent variable. Usually we always want a dependent and independent variable in the model, but we don't have it here. So what is the reason, and what kind of a model is this? Well, this is kind of an univariate analysis where we just need one variable for us. We just need in fact the only thing that we need is the status of the patient and the length of the time followed. So there are two variables, um, and then we just plot it by taking the unconditional probability. That is all we are doing it here, and Kaplan estimation is the one that we are using it here. Very simple but very powerful analysis. The same thing can be replicated in other fields also. We are analyzing death here. We can analyze anything, any event in the credit risk industry. We can analyze default, we can analyze delinquency, we can analyze bankruptcy, payoff, liquidation, so many things. Similarly, in the marketing industry, we can analyze when is the customer buy purchasing. So purchase is the event. When is the customer leaving the company, or being loyal to company. So these events can also be plotted as a survival curve, and we'll get to know at a portfolio level that what is the percentage of customers who are surviving beyond a particular time point. Okay, so that gives a fairly good idea about how the the business events happens across the time period, and it really is helpful taking very important decisions. That's pretty much about the Kaplan estimation. We can of course go on to the more complex estimation method, and then a couple of things we can do. We can compare survival analysis plots across different categories and check it out. That we will see in a separate session. For this session, that is all we will learn. Thank you.